Hi friends, how are you today? We're going to work on chapter 14, lesson 3, prisms and pyramids, though I shouldn't be on day 2, so just bear with me. I'm going to back up a little bit. Kaboom! We're on day 1, 14.3, prisms and pyramids. Our goals today are to be able to successfully state that I can identify and classify prisms and pyramids and identify the solid figure that can be formed from a net. What kind of solid figure could you form from a net? It's mesh. No, not that kind of net. We'll get there. Take a look at your vocabulary. Quite a few words we need to go through today. Base we've seen before, but we're going to use it in a different way. We've also got prism, pyramid, prism, net, vertex, base. Keep an eye out for all of those. All right. You should be able to describe a figure, identify a figure by its faces, edges, and vertices. A face is a flat surface made of a polygon. In this case, our cube has 6 square faces. An edge is anywhere where 2 faces meet. So this edge of the cube, this edge of the cube, that edge of the cube. And a vertex or vertices would be the points where more than one edge meets. Okay? Each face is formed by, top and bottom. Oh, see, I don't like this. It says the top and the bottom faces of a solid are called bases. Yes, but you could turn that square over and you've got a new top and bottom, and those could be the bases. So the bases are really 2 flat parallel surfaces on the flat parallel congruent surfaces on the figure. Okay, take a look, read through this, pause, and then continue. All right, let's do this. A cube has edges and vertices. Okay, a cube has 1, 2, 3, 4 edges there. 1, 2, 3, 4 edges down there, and then come on, 1, 2, 3, and 4 edges right there. The cube also has 8 vertices. Okay, an edge is a figure. In a figure is a line segment formed where 2 faces meet, as I said before, and a vertex is a point where 3 or more edges meet. More than one vertex would be vertices. Cube's got 6 faces, 12 edges, 8 vertices. Got it. Good. Oh, didn't we just do this? How many faces, vertices, and edges does the number cube have? The cube. The number cube. It's also known as dice. That's right. Dice. Well, we know it's got 6. I said 6. Aha. 8. 12. And then down here is a link. I'm not going to go to it, but you can go to it. But it's a great visualizer where you can pull up different 3-dimensional figures, and you can actually count the faces, vertices, and edges. It's pretty cool. If your teacher doesn't recommend you try it, I do. Okay. I know you can't link from my video, but you can link from the slides. That's an active link. So if you go back to Schoology, click on the slides, that link will be there for you. I was just thinking about that before it popped up too, so that's pretty fortunate. Okay, oh, I like this girl. She's always so confident. A prism, solid figure, 2. Oh, I said these things already. Parallel mean always the same distance apart. Congruent meaning equal or the same. 2 parallel congruent bases joined by rectangular faces. A prism is named according to the shape of its bases. So in this case, we have a rectangular prism because it's red top and bottom. Its red bases are rectangles. Okay, with a rectangular prism, such as this, any pair of opposite faces can be the base. So I could have a base and a base, I could have a base and a base, or I could have a base and a base. Okay, that's how it works with rectangular prisms. And like the cube, another rectangular prism, 6 faces, 12 edges, 8 vertices. Okay, memorizing those isn't super important. It's just being able to identify them. Now, looking at this prism, the bases are triangles, so it's called a triangular prism. Okay. We have triangular bases. Can this triangular prism be flipped to become a prism in another way? Oh, it's like I heard all of you say, no, Mr. McCarthy. No, it can't, because there are no other sets of parallel bases. The top and bottom triangle are parallel to each other, but none of the rectangular faces going around the side can be parallel to each other, and therefore they can't be the other bases. So this is the only way a triangular prism can be a triangular prism. Okay, take a moment. Name the parts of the prism. Identify the shapes of the faces. I'll erase it. Ready, set, go. Boop. 1, 2, 3, 4, 5. The shapes of the faces are all rectangles, but the bases are pentagons, making this a pentagonal prism. Okay? Don't judge my penmanship. Okay, let's continue. Why is this figure not a prism? Pause, ponder. Remember that a prism has two parallel, congruent bases. This has a single base, and then opposite of the base is a single vertex, which we'll find out as a special name, which is called the apex. But this is most definitely not a prism. It is a what? Absolutely. It is a pyramid. And if we name the pyramid by its base, what shape would this pyramid, or what kind of pyramid would it be? A pentagonal pyramid. Good. You guys really have a knack for this. I can just tell. Okay. So, and we just kind of actually did this part where it asks us to identify a pyramid. A pyramid has one base that can be any polygon. A polygon is a shape that has line segments for its sides. If it's a circle or an oval, then it's a cone. Okay. All the other faces are triangles that rise from the side of the base, and the triangular faces share a common vertex. Okay. A pyramid's named according to the shape of its base. So in this case, we have a square pyramid, and here's a rundown of its number of faces, edges, and vertices. Got it? Great. The base of this pyramid is a triangle, therefore it's a triangular pyramid. Now the cool thing is if you have a triangular pyramid where all the triangles, all the faces are the same, then that can be flipped over and be a pyramid in any direction. Okay? The faces of all prisms and pyramids are polygons. Boom! Let's name the parts of this bad boy and identify the shapes of the faces. I shall race you. Go. That's an edge. That's a vertex. The special top of the pyramid is called the apex. Keep going. You guys can pause me too in case I'm going too fast for you. This is a face. Also a vertex. I'm assuming this is a base. I'm assuming this is the edge as well. Shapes of the faces are all but one are triangles, and the base is a pentagon. Do you agree? Of course you do. Boop. Holy cow! Coming in under 10 minutes. Hang on. Oh my gosh. Oh, McCarthy, you're a rock star. That's it. That's where we're going to leave it. I'm going to come right back at you here in about 2 minutes in the same outfit, and we're going to finish up 14-3 Prisms and Pyramid. Later, taters.